Okay, welcome to video class number 11. Now, in this session, we are going to study about the inverse of bilateral transform. In the previous two videos, we dealt much about the Laplace transform. In video 9, I've just introduced the concept of ROC. Hope you have learned the concept of ROC and you have understood it. And in the video 10, we have done some problems which you are very much familiar in your S3 course. So you might have gone through all these videos and as aware of approaching or aware of the problems, and you hope that you know how to find out the Laplace transform and its inverse if it is a unilateral transform. Okay, now what is for just a recap of bilateral transform. Bilateral transform is the transform of a double-sided signal. Okay, so the signal can extend from minus infinity to plus infinity. So if you are taking the inverse of such a transform, those signals will be defined for different regions of the S plane, and the specification of that region is what is called as a region of convergence. So when you find out the inverse of such transform, it's very important to consider this ROC. Now in video class number 9, we have done three problems associated, we have found out the Laplace transform of three different signals. Okay, and while explaining the concept of ROC. So here are those problems. I have been tabulated the results. The first problem was e raised to minus 80 into u of t. We all know its Laplace transform is 1 by s plus a, but we found out the ROC as sigma greater than minus a. Do you remember that the sigma ROC, sigma is greater than a, is also represented as real of s greater than minus a. It's one and the same. Now similarly, we went on to the next signal. This is minus e raised to minus 80 into u of minus t, which is also having the same transform, but they differ in the ROC. ROC is less than minus a. And coming to the next signal, this is e raised to minus 80 into u of t minus e raised to minus bt into u of minus t, where a condition is there, modulus a is greater than modulus b. Now for that, it is a combination of these two transforms. Okay, that is 1 by s plus a. Here instead of b you have b, so 1 by s plus a plus 1 by s plus b, and the real of s lies in between minus a and minus b. When you draw the figure, or if you want to understand the region of operation, suppose this is minus a, this region will be the right side of this line, right? Of this line. This line is called as a line of abscissa. Okay, line of abscissa. Now this is the right side of the line. So in this case, it will be the left side. Say if this is 0 and this is minus a, this is the left side of this. And in this case, you assume 2 points, that is minus a and minus b. Okay, this region is what is represented by this. Okay, now you must have a clear understanding of this region of convergence when you start to do this bilateral transform. Okay, now let's start to do a problem on inverse, on bilateral inverse by bilateral transform. Find the inverse Laplace transform of, not this question, x of s is equal to 2 by s plus 4 into s minus 1. The ROC is given to be minus 4 less than the real of s less than 1. Now the ROC specified here is, I am again rewriting that ROC, it lies in between minus 4 of the s plane to 1. Now if you start to draw this, if you want, you can find out the region of convergence. That is, if this is said to be minus 4, this is the line of abscissa, and this is 1. If it is 1, this region, right, this region is what is called as the ROC, right? Okay, so this region is what is called as a ROC. Now that means this particular signal, that is this x of s, will exist only in this region. That's what is meant by this region of convergence. So what is the signal? What is going to be the signal corresponding time domain signal of this frequency domain which exists in between -4 and -1? That is what is being what is understood by asking the inverse. I repeat, by inverse it refers to what is the time domain signal of this transform which exists in between -4 and 1. Okay, now based on the ROC you can have the nature of the signal. So again, your attention to this table. I forgot to specify one more thing, that is, say, look at this. Let's classify these signals into 3. See, this one is a causal sequence, right? This one is a causal. Why it is said to be causal? Because this is multiplied by u of t. Now this signal is multiplied by minus of u of minus t, so this becomes a purely non-causal or an anti-causal signal. This is a combination of causal and non-causal, so we call this as a double-sided signal. Okay, so if you try any causal signal, not only this, any causal signal, you are going to get an ROC which is greater than a particular value. So that means it will be always on the right side of a particular point. Okay, now whenever the signal is a non-causal signal, that's going to be on the left side. That means it has to be less than a particular value. And if the region lies in between 2 points, just as in this example, then that signal is a combination of causal as well as an anti-causal. So you got an idea about the even before finding out your x of t, you got an idea about the signal, that is, this is a double-sided signal, right? This is a double-sided signal, and this is the information that you should know before finding out this signal. Now again, you are starting as you do in the case of a unilateral transform, 2 into s plus 4 into this is s minus 1. So you can have this as equal to a by s plus 4 plus b by s minus 1, and you can work out and find out the value of a and b. That is given as an exercise for you. You may just find out the value of so finally you will be getting an expression like this. You will get this a to be minus 2 by 5. So this becomes minus 2 by 5 into, I am going to write like this, 1 by s plus 4, while b you will be getting as 2 by 5. So this will be 2 by 5 into 1 plus 1 divided by s minus 1. Okay, now how will you find out the inverse? So as you know how to find out the inverse right now, if you have really studied the 10th video. Now what happens? Just forget about these conditions right now. What is the Laplace transform, or which signal's Laplace transform is 1 by s plus 4? We know that it is e raised to minus 40. Just write like that. Which is this? This is plus 4. That's why it is written as minus 40. So if it is minus, this will be e raised to minus t. Right? Okay. Now the question is, there are two. This signal has got two parts. One is e raised to minus 40 part, and the other one is e raised to minus t. Now the next question is, this is a double-sided signal. That is a signal similar to this. That means one of the part has to be causal, other one has to be a non-causal. Now the thing is that, which one will you select as non-causal and which one will you select as a causal? Now look at this. You can rewrite this ROC again, right? ROC as, I am going to write this, divide this ROC as ROC, RE of s is less than 1, right? When you read in this line, this is real of s is less than 1. Now if you read in the reverse operation, real of s is greater than minus 4. Okay, so you can write this, real of s is greater than minus 4. Okay, Now, when you individually take the the Laplace transform and find out its ROC, which do you think? Which signals corresponding ROC will be this? Yeah, definitely you have an e raised to minus 1 here, so you can by simple observation you can say that this ROC corresponds to this, while this ROC corresponds to this signal, right? So if this is corresponding to e raised to minus t and Re of s is less than 1, and what is Re is sigma less than per any value will be a non-causal signal. So that means, how will you make a non-causal signal? Here e raised to minus at is converted into a non-causal by putting a minus into u of minus at. That means you must put here minus into u of minus t, right? U of minus into u of minus t into e raised to minus t, or you can put like this, that will be a standard form, u of minus t, minus into, you have a negative sign here, that into u of minus t. Now what about this? This is the real of s greater than a value. We know that greater than any value is a causal sequence, so this has to be multiplied by u of t. So what is your x of t? X of t is equal to e raised to minus 4t into u of t minus e raised to minus t into u of minus t. Okay, so this is it. Okay, now the next question, you have the same question, find the inverse Laplace transform of, so this is find out the inverse Laplace transform of x of s2 by s plus 4 into s minus 1, but your ROC is different. Okay, now second case, the ROC, second question is ROC is given as real of s is greater than minus 4. Okay, real of s is greater than minus 4. That is what the second ROC. Now here again you have the same question. Okay, same question, but the ROC is different. Now the combined signal is having a ROC, real of this is greater than minus 4. So let me just try to draw the figure of that. So what is this? ROC is, so I'm going to rewrite that. ROC is real of s is greater than minus 4. Now how to plot that? So this will be minus 4, right? ROC is greater than minus 4 means the region will be the whole of the right half of this plane. And what is the meaning of this? What is the meaning of this question? You are supposed to find out the time domain signal, okay, time domain signal of this transform which exists in the region from minus 4 to this. This is the question between minus 4 and 1. This is a question that find out the signal, find out the time domain signal which exists for all the values, all the s planes starting from minus 4 onwards. Okay, so that is your real of s. Now what is the inference that you get about this x of t? The resulting x of t, since it is Re of s is greater than minus 4, we know that anything greater than minus 4 is a causal signal. So this is going to be a causal signal. Now the steps are till this point, the steps are the same. So from this we can again write your x of t as, so as usual, what is this? E raised to, write like this, e raised to minus 4t plus e raised to plus t, right? This is 1 by s minus 1. It is exactly the same. Now this x of t has to be causal, meaning these two signals are to be causal. Now how to make it causal? It is very simple, that is multiplying by u of t, right? This is it. It's such a simple problem. Now you have the third, now you have again the same question, that is x of s is equal to 2 by s plus 4. The third question is ROC is real of s is less than 1. Okay, Re of s is less than 1. Now that is your next ROC. So let's see, the ROC is real of s is less than 1. And how will you draw that? R of C is less than 1 means this is your 1 point, and the ROC is going to be like this, no? All of the S plane that is less than minus n. And what is the meaning of this question? What is the meaning of this question? That is to find out the time domain signal corresponding to this transform which exists from all of the S plane less than the point 1, right? Now we know that this real of S is less than 1 means what? It has to be a non-causal sequence. Again, as we have written here, x of t is again what? X of t is again e raised to minus 40 plus e raised to plus t. Now we know that these two has to be non-causal. That means it has to be multiplied by minus into u of minus t. So this will be minus, again you have a minus into u of minus t, right? Is that clear? So this is it. So this will be, now don't forget to write 2 by 5. I forgot that. So here also you have minus 2 by 5. Here you have 2 by 5. Here also you have 2 by 5 and minus 2 by 5. Okay, don't forget to put this. We usually commit such mistakes, so don't forget this. Always you must be very careful about this coefficient. Now what do you infer from this? We have got only one x of s, and that x of s represents three classes of signals, isn't it? First one is this is a double-sided sequence. Okay, first one I'll show. First one is this one, right? This is a double-sided sequence. Now what about this? This is a causal sequence, and this is a non-causal sequence. So hope you understood the concept of ROC. Why ROC is so important? Because x of s always represents, x of s can represent more than one time domain signal. So in order to distinguish these signals, ROC is to be specified, and this is only valid, or this is only made into use when you consider bilateral transform. Okay, here also you should put minus 2 by 5. This is minus 2 by 5. This is 2 by 5. Don't forget to put this. This is very important, this coefficient. Okay, now next is system analysis using Laplace transform. Now we are going to apply, that is, the next portion is, you can say it as the application of Laplace transform. Now the Laplace transform, as far as signals and systems are concerned, this is used mainly for system analysis. Now we have already studied about system analysis in time domain. We have come across two different methods. One is solving a differential equation. Okay, now another one is the impulse response method. Impulse response method. So in solving a differential equation, we will solve a differential equation classically. That is, I mean to say that you will first find out the homogeneous solution. Second is a particular solution. From this you will find out the natural response. In combination with particular solution, we will find out the forced response, and when you add these together, you will get the total response. Now as you have seen that it is a time consuming operation. In solving a differential equation, it takes a lot of time. Not only that, that is a bit tedious as well. Now when you come to the impulse response also, so by solving a differential equation means to find out your I of t. Similarly, you have one more thing. If you have something called as h of t is called as the impulse response of the system, and if you know the input, then you can straight away use for any LTI system, this is x of t star h of t. And we have seen even this convolution operation is also a bit complicated and it is also tedious, right? Now the system analysis can be done by using Laplace transform. Now, what is the meaning of Laplace transform? It transforms any time domain signal into a frequency domain. So what you do is you're actually using the system analysis in the application of Laplace transform also, you are resorting to these two methods. But what we do is we won't be solving a differential equation according to the classical approach. This is called as a classical approach. Instead of that, we will transform this differential equation into the frequency domain equation. Okay, into frequency domain equation. Similarly, you will transform this equation again into its frequency domain equation, so that this becomes y of s, right? Now here also you will be getting, so you will understand when you do the problem, and just here also you will get y of s. Now how to get, what do you mean by system analysis? It is not to obtain y of s. The system analysis, by system analysis it refers to obtaining the output of the time domain. Now once if you receive this y of s, how will you find out y of t? The answer is very simple. Both the cases find out the inverse. Okay, that's very simple. So first and the foremost thing is, this is a differential equation. When it is transformed to frequency domain, that becomes a simple linear equation, and which is very easy to solve rather than solving a differential equation. So that is the ability of frequency transformation, or that is what the Laplace transform does, transforming a time domain equation into frequency domain. So what it does is it transforms time domain equation into frequency domain. This is very important. This is what the Laplace transform does, and that is the power of this tool. Okay, no more theories regarding this. I am straight away doing some problems associated with this. Now, system analysis using solving a differential equation. Let's move on to that heading. So first is system analysis using solving a differential equation. Okay, now the example is, you are given a differential equation d square y of t by dt square plus 7 dy of t by dt plus 12 into y of t is equal to x of t. The initial conditions are given. Y of 0 is equal to minus 2. This is not plus 2, this is minus 2. Y dash of 0 is equal to 0, and you are asked to find out the step response of the system. Okay, you find out the step response. Okay, now we have done a similar problem in our class while we dealt with the differential equation. Now in this how to solve a differential equation using Laplace transform. This class is actually meant for system analysis using Laplace transform. How to use this Laplace transform to solve this equation. Now while you complete this, you will understand the easiness of using Laplace transform. Now before doing this, we should assume that the only unknown is y of t. So we can assume the Laplace transform of y of t is y of s. Okay, now what about x of t? X of t is known because you are asked to find out the step response. So your x of t is nothing but it is equal to u of t. The Laplace transform of x of t will be equal to 1 by s. For the meantime, I am simply using it as x of s, and finally we will substitute for x of s as 1 by s. Okay, now what is the first step? First step is, say, call this as equation 1. Applying Laplace transform throughout equation 1. Okay, now what happens when you apply Laplace transform? So that is Laplace transform of this whole equation. That means what will be the Laplace transform of this one plus Laplace transform of this one plus Laplace transform of this one is equal to Laplace transform of x of t. Now I'm going to show you a property which we have already studied. Okay, this is the Laplace transform. If you have x of t whose Laplace transform is x of s, then the Laplace transform of, if you have Laplace transform of x of t is x of s, then what is the Laplace transform of the derivative? It is x into x of s minus x0. What is the second derivative? It will be s square x of s minus s into x of 0 minus x dash of 0. That's what we are going to apply here. Now applying that, so you can write the first equation. So what is this? This is s square into y of s minus s into small y of 0. What is that? That is the initial condition. Then the derivative upon 0, y dash of 0. Okay, right? Now next is plus 7 into, okay, 7 you should take as a common thing. So this is very important. 7 into s into y of s minus y of 0, because it is only dy by dt, so you have only y of 0. Remember, you must be very careful when you deal with double derivative. You will be having minus sy0 and a y dash of 0. This is this plus 7 into y of 0 plus 12 into y of s is equal to x of s. Okay, plus 12 into y of s is equal to x of s. Okay, now, okay, so this is the expression that we get when we apply Laplace transform throughout the equation, and again the data is written here. Y of 0 is minus 2, y dash of 0 is equal to, and so you can have a substitution of all these in this equation, and rearranging you will get this as y of s is into s square plus 7s plus 12 plus 2s plus 14 is equal to 1 by s, or this y of s is equal to y of s into s square plus 7s plus 12 is equal to 1 by s, okay, minus, okay, you can 2s plus 14. Okay, this is minus of 2s plus 14. Now you can have your y of s is equal to 1 by s into s square plus 7s plus 12 minus 2s plus 14 divided by s square plus 7s plus 12, right? Okay, now then next is you are finding out the LCM of this s into s square plus 7s plus 12. So when you take the LCM, this will be 1 minus, you have an s multiplied, right? So this will be minus 2s square plus 14, it is not plus, it is minus 14s, right? So this is it. This is 1 minus 2s square by, now you can have this one more step, 1 minus 2s square minus 14s divided by s into, what is this, s square plus 7s plus 12 is s plus 3 into s plus 4, s plus 3 into s plus 4, right? S plus 3 into s plus 4. Now you can have this, resolve this into partial fraction, a by s plus b by s plus 3 plus c by s plus 4. Okay, now you can find out your a to b. Okay, you can find out your 8. You can have this this y of s. Okay, this is 1 minus 2s square minus 14s by s into s plus 3 into s plus 4. You know how to perform this. Now using this you can find out a, b and c, and you will have to work by yourself to find a to be 1 by 12, b to be minus 25 by 3, and c is 25 by 4. Okay, now when you get that, you can substitute your y of s as y of s equal to, look, It is a by s. In this you are going to substitute. So this will be 1 by 12 into 1 by s, okay, minus, this is 25 minus 25 by 3 into 1 by s plus 3, now c by s plus 4. So this is plus 25 by 4 into 1 by s plus 4, right? Okay, 1 by s plus 4. Now from this you can find out what's the meaning of analysis. Analysis always refers to finding out y of t, right? Now what is y of t? Y of t is just taking 1 by s is the Laplace transform of u of t, minus 25 by 3 it into 1 plus s by 3, it is the Laplace transform of e raised to minus 3t, plus 25 by 4 into e raised to it is 25 by 4 into e raised to minus 4t into u of t. Okay, you can write this as into u of t, no problem. Okay, because we are, whenever we do the inverse in a problem, we simply assume that as a unilateral Laplace transform. You don't have to worry about the ROCs and all those things. Just it is a, so you can simply write it as into u of t. Okay, now this is actually the step response. This is the step response. So just note how many steps you required. Just the primary thing that we found out is, say, in your while solving a differential equation, you have various steps. That is, to find the natural response, you need to find out the homogeneous. First you need to find out the particular solution, and total solution you need to sum up, and all these things is a lengthy process. While when it comes to here, you have an equation, just find out the Laplace transform and substitute all that you have. There is no separate steps for that. The initial condition is substituted, x of s is substituted. I think when you just look at it, you have 2 or 3 steps to arrive at this. So that shows the easiness of this method. And one more analysis, when you come to the analysis part, so what is the difference between these two part and this one? Just think, what will happen to this part when t tends to infinity? Okay, what is the meaning of t tending to infinity? That is the steady state of a system. This is the system response. We are concerned about the steady state. Okay. Now, as t tends to infinity, this e raised to minus 3t and minus 4t becomes 0. Okay, this reduces to 0 at t tends to infinity. So this is actually the response. So response consists of two parts. A part which reduces to 0 as t tends to infinity, a part which remains as such as, okay, so this must be your steady state, right? And this is your transient state. Okay, this is what we studied in network, in RC circuits and RL circuits, RLC circuits, etc. Okay, or in other words, you can say that this is the zero state response or the forced response, right? And this must be what? This must be your natural response or zero input response. Okay, so okay, now the next one is analysis by impulse response using Laplace transform. That was the second type of analysis, time domain analysis, which we have seen. Now, as I told you, that this can also be converted into its frequency domain. Okay, now the basic thing is, so suppose you have a impulse response h of t, and analysis always refers to finding out the output for a particular input. That means you want to find out y of t given x of t as the input. So this is actually, we know that y of t is equal to, for any LTI system, this will be x of t star h of t, right? Now we have seen in our previous classes, that is I think it is in the 10th video, that while we were doing the time convolution, and I think I have proved that as well. So look at this. This is the time convolution. If you have two signals x1 of t and x2 of t whose Laplace transform is known. Now, if that is the case, the Laplace transform of the convolution will be just the product of this. Look at the easiness of that. So that means if you are going to apply this property here, you can find out the Laplace transform of y of t as the Laplace transform of what? Laplace transform of x of t star h of t, right? Now, if you can assume that the Laplace transform of x of t is equal to x of s, while Laplace transform of h of t is equal to capital H of s, then by applying this convolution property, what do you say? Say this is x1 of s, this is this is x1 of s and x2 of s. Now, if you convolve this, the Laplace transform of that convolved signal will be just the product. Okay, so what you need to do is, so your y of s will be the product of the individual Laplace transform, that is x of s into h of s. Okay, once you find out, now how will you arrive at what is the meaning of analysis? Analysis still remains, the meaning is y of t, finding out y of t. Once you get y of s, you can take the inverse of this to obtain your y of t. Look at this, how much simple it is, the procedure. You don't have to use the complicated convolution expression. Instead of that, what you're doing is just you're resorting to simple multiplication operation and thereby finding out the inverse to arrive at the response of the system for any input, right? So this is the thread of this analysis. Okay, now listen please. So let us mark this as equation 1. Now from this equation 1, you can write another expression for h of s. H of s is nothing but y of s by x of s. That is the Laplace transform. This is the Laplace transform of the output to Laplace transform of the input. And if you can assume the initial condition to 0, then you can call this as the transfer function of the system. Transfer function of the system. Now, what is the difference between the analysis using this transfer function approach and the other thing, the differential equation? In the differential equation, we will consider the initial conditions, while in if you analyze using the transfer function, then the initial condition is assumed to be 0. But in many of the practical systems, this may not be giving you an accurate result, but it can be used for simple analysis of any system. Okay, so this is what is called as a transfer function. Now, sometimes questions can be asked. You may be directly given the transfer function, okay, and you will be asked to find out the impulse response. That's very simple, because if you are given with the h of s, what is y of s by x of s? What is x of s what is the Laplace transform of an impulse signal? It is equal to 1. So y of s is equal to h of s. Now, if you get the inverse of that, that will be your impulse response. Okay, so that is a very simple thing. Now, sometimes the question may be given like this. Say you may be asked to find out, say you will be given with, say, some h of t, the impulse response, and say some x of t is given as an u of t. Okay, so you may be asked to find out the step response of the system. We know that what we do is, we know that this is u of t star t into e raised to minus t, say, right? So instead of this, what you need to do is, if you know the Laplace transform of this signal, okay, Laplace transform of the signal t into e raised to minus t, okay, or Laplace transform of the signal, you can straight away write this as the product of 1 by s into what is t into e raised to minus t. What is e raised to minus t? This is 1 plus s plus 1 the whole square, right? So this is what is your y of s, right? Now, using this y of s, this is your y of s, right? Now, if you get this y of t, that is finding out the inverse, you will be getting the y of t, right? Finding out the inverse, you will be getting your y of t. Look at this again. I've just shown an example. You have h of t may be given. You are asked to find out the step response, meaning input is step. So you can simply substitute. Now instead of going through convolution operation, you just need to multiply this and take the inverse of this. So this is the theory behind this. Now not only that, you must know how to get impulse response from a differential equation. Okay. Now it is the same question that we have done just now, that is to find out the it is the same question. Look at this, d square y, the same question, but the question is to find out the impulse response of the system. Now to find out the impulse response, this doesn't mean that you can solve this. So suppose if you are asked to solve this expression, you should apply, you should go in this. If you are asked the question that to solve this, you need to go in this way alone, right? So that is how we did. Now the question is to find out the impulse response. So in order to find out the impulse response, you should have h of s. What is that? H of s is the transfer function. Now how is transfer function defined? It is the Laplace transform of output divided by the Laplace transform of the input at all the initial conditions to 0. Now we know that in this question, in the previous question, the initial conditions are given. You don't have to consider those initial conditions to find the transfer function. Do remember, if the question is to find out the impulse response, then you need to find out the transfer function. If the question is to solve the differential equation, you need to consider all the initial conditions. Be very careful in that. Now how to get the impulse response from a differential equation? So this is s square into y of s. Do you need the rest of the term? Minus, so this will be minus s into y of 0 minus y dash of 0, right? Plus 7 into s into y of s, right? Plus 7 into minus 7 into y dash of 0 plus 12 into y of s is equal to x of s. What will happen to these two terms? These two terms become 0 because we are actually going to find out the transfer function where the initial condition is 0. So similarly, this also becomes equal to 0. So that you will get your y of s as y of s, you can take the y of s as s square plus 7s plus 12 is equal to your x of s. Now what is your h of s? H of s is equal to y of s divided by x of s, which is equal to 1 by s square plus 7s plus 12, or this is equal to 1 by s plus 3 into s plus 4, right? So this is actually your transfer function. This is your h of s. Now once when you find out the transfer function, what is transfer function? Transfer function is y of s by x of s is equal to 1 by s plus 3 into s plus 4, right? Now if you are to find out the impulse response of the system, what do you mean by impulse response? Impulse response is x of t is an impulse signal, right? Del of t. Now what will be your x of s? We have already found out this to be equal to 2. So when you substitute x of s to be 1, your y of s is the transform of the impulse response, right? So this will be 1 by s plus 3 into s plus 4, right? Now this same equation can be written as a by s plus 3 plus b by s plus 4, that is equal to 1 by s plus 3 into s plus 4, right? Now this is equal to 1 is equal to a into s plus 4 plus b into s plus 3. Now at s is equal to minus 4, at s is equal to, when s is equal to minus 4, you will get this a is equal to minus 1 and b as 1. Now what to do? So this is your 1 by s plus 3 into s plus 4, isn't it? 1 by s plus 3 into s plus 4 is equal to minus 1 by s plus 3 plus 1 by s plus 4. Okay, so this is your y of s. Okay, this is your y of s. We need to find out now what is this y of s. Actually we are going to find out the impulse response, right? So x of s is equal to 1, so you will be getting your y of t to be, this is e raised to minus 4t minus e raised to minus 3t into u of t is your impulse response, or this is what is called as your h of t. Okay, now if you have the impulse response, how will you find out the step response, for example? Now if the input is given as u of t, you are given with this h of t is given. Now how will you find out your new y of t? That is y of t, or this is actually your step response. How will you find out the step response? The step response is nothing but, it is, here you are using y of t equals what? X of t star u of t. That means you have to convolve this signal with respect to u of t. But we know that from convolution property, it is not required to do the convolution in time domain. Instead of, you can convert it into frequency domain, so that you can convert this into instead of doing convolution, you just need to perform the multiplication operation. So what is your x of s? X of s is 1 by, this is x of s, star h of t. This is star h of t. This will be into h of s. So this is 1 by s into, what is h of s? H of s is 1 by s plus 4 minus 1 by s plus 3, right? So that you will get this as 1 by s into s plus 4 minus 1 by s into s plus 3, right? Now you know it is a very simple thing, you know how to solve this. So find out the y of t corresponding to this. How will you find out the y of t? A by s plus b by s plus 4 minus a c by s plus c by, okay, or you can take this outside. Anyway, this is how you need to find out the y of t. You can separately find out this y of t and subtract this, so you will be getting your y of t. And what is that y of t? Y of t is going to be your step response. You may do it by yourself. It is very simple. Okay, so we learned how to use the Laplace transform. The primary thing is using Laplace transform to solve a differential equation. Now upon solving, you will be able to get the forced response, and that is by applying the initial conditions. Now you can also have the impulse response from a given differential equation. Now that is by finding out the transfer function. In the transfer function approach, you need to consider the initial conditions to 0. So your ratio is going to be the transfer function. From the transfer function, if you apply this x of s to be 1, you will be getting the impulse response. Now once the impulse response is obtained, you can use this expression to find the output response for any input, but you don't have to use this convolution. Instead of convolution, you can use the convolution property of Laplace transform, which is a simple multiplication. You just do the multiplication and find out your response. So these are the things that we need to. So we studied about the analysis using differential equation, as well as analysis using impulse response using Laplace transform. Now even if the question is asked in the second module regarding impulse response and so on, you can resort to this example unless it is stated as some classical method or something like this. If it is not specified in the question, you can use this, you can apply this Laplace transform to find the answer.